because vacuum can't really, well, you can't suck. How do you design and build and control something that needs a rocket engine to run, and the rocket engine itself needs this one to run? That is a hard nut to crack. I'm talking about the pump. You have seen me struggle for years now with this pump, and there is a reason behind it. The first design is basically a hydrostatic pump. It's using pressure to move liquid from the fuel tank to the pump and to the engine. But we realized pretty soon that it consumes a lot of gas. For a 60 seconds run, we need almost between 260 and 260,000 liters of gas for a 60 seconds run. And that is just for the booster. And put that into scuba diving tanks, well, you need like 15 of them. And you can imagine how much weight that put on the rocket. So no, we have to redesign the pump, and that's what we did. So how can we down lower the amount of gas that is required to the pump? Well, we introduced vacuum. For the current situation, we use the engine for that. But in the beginning, we had to use a vacuum compressor to create that vacuum. So what we're basically doing is we use the vacuum to suck the fuel from the fuel tanks, and using positive pressure from the scuba diving tanks to pressurize the pump. But we had to redesign the entire system for that, and that's what you see today's pump, and that's why it's taken so long time to do. So it was a really hard nut to crack, let me tell you that. And with a big B in the butt, we still have some problems. During the last couple of months, you have seen me struggle with this pump, and those pressure drop we get in the cycles. One cycle is when the pump is emptying and refilling the chambers. That is one cycle. This problem with the pressure drop occurs around the third cycle. I have actually no idea why it's happening, and I'm trying to figure out how. You have seen me going through the electronics. We have redesigned it. We have redesigned the pump. We have rebuilt the pump. We have rebuilt the electronics, and it still remains. I've seen this pressure drop every single time we're doing those tests, and we have done the test like 12 times now. So we're using 300 liters times 12, so it's a lot of water. So I hope my landlord is... I can hear you asking me now, Sebastian, how can you see inside the pump while it's running and see what the liquid is doing? Well, you can use an X-ray machine for that, but I don't think there is any company around here that will borrow us an X-ray machine.
No, 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 no.
So what do we come up with then? Well, the best next thing, plastic bottles. Those are transparent plastics, so we can see what's going on inside. So what we did is we built a replica of the pump, or kind of a replica. So we're using two bottles, plastic bottles, and they are transparent, so we can see what's going on inside. So what we're doing here is this lower bottle is basically the fuel tanks. We will fill this up with water, and the top that represents the pump. We fill it up just above this level pipe that is going on the outside on the real pump. So on the top here we have a level sensor. So what we're doing is we're squeezing the lower part, the lower bottle, and force the liquid upwards to see what's going on inside this level sensor piping here over here, because we believe the problem is coming from this pipe and this level sensor. Welcome to the Mr. Whiteboard, and for you guys who didn't really understand, what I did in this test was to test this level sensor pipe over here. So what we have here is the mock-up of a pump chamber. So this is the chamber, and this is the pipe that's going on the outside where we have the level sensor in. So what we did in this test is we forced water from the bottom of the pump chamber, and that is forcing upwards really fast and filling up the chamber. So the plan was to have a same level inside the pump chamber as in this level pipe over here. They should be in the same level in theory due to gravity, but they are not. That is because we are, when water rushing upwards like that very fast, we are building a gas pressure on top of the water, which increase when the gas is going into this level pipe over here, which basically force the water back into the pump while this chamber is filling up. And that is no good because we have a level sensor over here connected to the computer, and that is registered when the water level or fuel coming up to the top of the pump so that it continues its sequence. But now we have a gas pocket over here, as I could see in the test I did, which we need to get rid of somehow. And I think this is caused by the drain system, the drain valves, because they are too small. So what I've done in this test, or I will do in this test, is to replace this pipe to a much larger pipe so it can drain a lot of more air from the chamber. So we will see if that works. Otherwise, if that doesn't work, I have to go back to the electronic part, check out that level sensor. Well, I can hear you saying, oh, that dude doesn't know what he's doing and he doesn't understand what he's saying he's doing. The thing is, I totally understand the system because I built it, and I also have figured out what is happening inside the pump during those tests. And the thing is, when you are exploring new territory, like which I do with this pump, things will happen. And when you're fixing one problem, that can affect other things, and that's what we see in those tests. So yeah, I know what is happening, and I'm trying to figure out how to fix it. But there are many ways. There is countless ways we can test this, and I have more ideas than you know. So I will try those out. But I will go back to the electronics part and look over those level sensors. I have some other sensors I will test out too, see if they are better. Anyway, so I will put this project on hold for now, and I will see you guys in the next upcoming update on this one. So see you. Have a nice day.